Next problem. Find the Z transformation of cos n theta and sin n theta. Also find the Z transformation of cos n theta by 2 and sin n theta by 2. So same thing, Z of cos n theta is nothing but Z transformation of cos n theta. Z of sin n theta is Z transformation of sin n theta. Right? We'll see the solution. Again, we are using the same formula, Z of a power n, which is equal to Z by Z minus a. So taking a, which is equal to e power I theta. So a power n, which is equal to e power I theta whole power n, which is nothing but e power I n theta. So that is equal to, using De Moivre's theorem, cos n theta I sin n theta. So Z of e power I n theta, which is equal to Z of e power I theta whole power n, right? Both are same, right? Is equal to, so using that formula, Z of a power n, which is equal to Z by Z minus a. So here we are taking a, which is equal to e power I theta. So you will get Z by Z minus e power I theta in the right hand side. The left hand side, so again we are using the De Moivre's theorem, e power I n theta, which is equal to cos n theta plus I sin n theta. So right hand side, Z by Z minus e power I theta. So separating the left hand side, separating the Z transformation for the each term, Z cos n theta plus I Z sin n theta. The right hand side, we are using the De Moivre's theorem for e power I theta. So Z by Z minus cos theta plus I sin theta. So taking the minus inside the denominator, Z by Z minus cos theta minus I sin theta. Now we are multiplying the conjugate of the denominator. In the conjugate, you are having Z cos theta, that is real term, minus I sin theta, that is imaginary term, right? So conjugate of Z cos theta minus I sin theta is nothing but Z minus cos theta plus I sin theta. So you have to replace the sign of the imaginary part only, right? Z minus cos theta plus I sin theta divided by Z minus cos theta plus I sin theta. So in the numerator, multiplying with Z into Z minus cos theta plus second term Z into I sin theta, I Z sin theta. The denominator, we are using a plus b, a minus b formula, that is a square minus b square. Here a, which is equal to Z minus cos theta, and b, which is equal to I sin theta. So a square, so Z minus cos theta the whole square, minus b square minus I sin theta the whole square, right? I square is minus 1, so minus into minus plus, so denominator will become plus sin square theta, right? Now in the numerator, we are having the same, right? Z into Z minus cos theta plus I Z sin theta. Denominator, we are expanding the denominator using a minus b whole square formula for the first term, a square Z square minus 2ab minus 2Z cos theta plus b square plus cos square theta plus sin square theta. Grouping cos square plus sin square in the denominator, you will get to 1. So numerator as it is Z into Z minus cos theta plus I Z sin theta. Denominator Z square minus 2Z cos theta plus 1. Now we separate the numerator real part and the imaginary part on the right hand side. So left hand side as it is Z cos n theta plus I Z sin n theta, which is equal to real part Z into Z minus cos theta by denominator Z square minus 2Z cos theta plus 1 plus I into the imaginary part Z sin theta divided by the denominator Z square minus 2Z cos theta plus 1. So equating real and imaginary parts on both sides, you will get Z cos n theta, which is equal to real part of the right hand side Z into Z minus cos theta by Z square minus 2Z cos theta plus 1. So imaginary part of left side is Z sin n theta, which is equal to right side imaginary part Z sin theta divided by Z square minus 2Z cos theta plus 1, right? So that is equation number 1. Then that is imaginary part is equation number 2. Now replace. So we are going to the next part. So replace, put theta is equal to pi by 2 in 1 and 2. So you will get cos pi by 2 into n. Replacing theta by pi by 2. So you will get cos n pi by 2. The left hand side, which is equal to, so z into z minus cos pi by 2 divided by z square minus 2z cos pi by 2 plus 1. We know cos pi by 2 equal to 0. So z into z minus 0 by z square minus 2z into 0 plus 1. So z of cos n pi by 2, which is equal to z square. Z into z square in the numerator. Denominator you are having z square plus 1. Now z of sin n pi by 2, which is equal to z into sin pi by 2. We are putting pi by 2 in the second equation. So you will get z sin pi by 2 by z square minus 2z cos pi by 2 plus 1. Sin pi by 2 value 1, cos pi by 2 equal to 0. Replacing z into 1 in the numerator. In the denominator, z square minus 2z into 0 plus 1. So you will get z by z square plus 1. That is equal to sin n pi by 2. Z transformation of sin n pi by 2, which is equal to z by z square plus 1. Right. Next problem, small problem. Z of 2 into 3 power n plus 5 into minus 2 power n. So we will see z of 2 into 3 power n plus 5 into minus 2 power n. We return as 2 into, right, z of 3 power n plus 5 into z of minus 2 power n, right? So we know a power n formula, right? Z by z minus a. So instead of a, in the first term you are having 3. So 2 into z by z minus a, that is equal to 3. Plus 5 into, here in the place of a you are having minus 2. So 5 into z by z of minus 2 z plus 2. Thanks. We'll see you in the next video.